So the big idea here for a neural network is to try and mimic how the human brain works. Now we know the human brain is, the most complex system we know. We're still learning about it, but so far, based on our classical understanding, classical physics, there's an entire part of quantum physics consciousness that goes on with the human brain. But for classical understanding, we know that we have a bunch of neurons connected, billions of neurons actually connected, and we have signals from one neuron to the next and to the next and to the next in this complicated network, right? So you have sensory information coming in through your senses, your five senses. You smell some gas, you touch something that is cold, it sends these input values to your brain, and there are specific weights assigned to each signal down a neuron to the next. So in this complex maze, right, we have all these signals coming in, and based on the weights, it hits some value, a threshold value, and if it's high or less than that threshold value, it is, sends to the next thing. So an example is if you have a lot of discipline, a lot of experience. There are people who have a lot of discipline with hot materials, so they have increased threshold value for pain, so they can touch a hot surface and they won't have that reflex of pulling away from it. But for regular mortals like us, once you touch a hot surface, there's a reflex action that pulls your hand back, because that, the signals and the weights, exceed the regular threshold value, which is low. And that goes into the next phase, which causes you to react. So that's the big idea for the neural network, right? You have this complex system where you try to learn. That is what the brain does. You have some input information, it processes it, and it has some output. So a child growing up has a bunch of these neurons learning, and that is what we are trying to mimic with neural network. This complicated structure has some inputs, as you can see, and some weights, as I mentioned. So if it exceeds this threshold value, in this particular case, we just use a 0 and a 1. For this case, I'll get to it later. We push it to this transfer function, right? Now, with the transfer function, it could be anything. It could be a linear function, it could be a logarithmic curve, whatever. But the default setting for this particular software is something that we call a sigmoid function, and I'm going to pull that up right now. It's here. So this is what the sigmoid function looks like. It's a specific type of logistic curve. I'll put up links on the help file if you want to learn more about logistic curves, all that. But this is the default, right? And this is typically used to study natural behaviors. So they typically start very slow, small beginnings, and then they approach some, they have accelerated growth rate, and then they approach some climax value. So that is what we use for the default setting here. Now, for actual neural networks, there's a lot of things that go into it. There's a lot of physics, a lot of signal processing, a lot of statistics, really, really big on probability, a lot of linguistics, I think, say psychology and neuroscience. But this particular software is a crude representation of neural networks as we have it today. So I think this was developed in about the 2000s, this particular software. And for the purpose of our applications in this course, it does more than you want it to do. So you're going to have to feed it with some input, parameters. We're going to train it first, right? And the training process is we tell it, hey, these are our input values. These are our output values. Learn it. Now, when you learn from this data, you try and predict to yourself. And based on some parameters that we will go in and change based on our understanding of the data set, the system is trained. So now that the system is trained, we give it something completely new and say, hey, remember the first data set that I gave you? Okay, I want to find if this data set. Sorry, I want to find what happens when I give you something else. So based on the parameters of the first data set, based on what you've learned, tell me what I should expect, right? And we will go more into that when we get to the specific part for the training. But we're going to go down a little bit here and look at this PDF, what else it tells us. So here we talk about the neural structures, right? As I said, the input layer have a bunch of input parameters, and then you have your weights here. There's a hidden layer here where we use this default. I'm gonna pull that up real quick. We use this default equation to try and figure out how many hidden layers someone should have. And again, we'll come to this secondly. Sorry, some other time when we're talking about the training. And then we have our output layers, which basically matches what your input layer is, right? So this is a feed-forward network. There's something else called a recurrent network where, okay, you push your values here all to the end, and you go all the way back to the beginning based on, some set parameters and say, okay, let me change this a little bit. Let me alter this. Let me increase or decrease this. And that is the recurrent network. For the purpose of, this, we're going to stick with a feed-forward network. So that makes things a little bit easier. Now, the learning rules, as I said again, if you have a linear trend, you have your X variables, you have your Y variables, you can fit a curve to it. If it's a linear curve, you know that, Y equals mx plus c. It's pretty straightforward, right, to help you predict. So now for some value of X, if it follows a linear trend, you should get some value of Y. But, excuse me. But now we have a situation where it's not just X and Y, right? It's X and it's this and it's this and it's this, all affecting what final Y you get. So your input value is X, but whatever goes into the final Y has so many different variables that we're trying to get an accurate prediction. That is why we use a neural network. So we will specifically into examples when we start talking about the training session in the next video. But the learning rules basically, is based on some correction method, right? If your calculated predictions, right, are too big or too small than what the actual values of output are supposed to be, then you can adjust your weights a little bit and do better prediction. So this is the error correction method. And again, we'll talk about the design of the hidden layers more in the next video. But the idea of the backpropagation network here is that the system you give the system an input value and an output value. And we say, okay, learn this and tell me what you think should be the predicted value. So during the training session, that's what we give it, right? You give it data, input and output, and the system calculates some prediction. Now, if this prediction is compared to what the output value is, and the error is, not something we want, then we have to go in and change it, right? So this, is essentially what the backpropagation network does. There's a lot of math if we want to go into that specifically, but I believe this is the general overview of neural networks.